Okay, so 6.1 radian measure. Angles can be measured in degrees so that one full turn is 360 degree and half turn is 180 degree. You already know that. An alternative way to measure angles is in radians. So how do we get the angle in radians? The size of an angle is expressed in terms of the length of arc term A that subtends the angle theta at the center of a circle with radius r. So A is proportional to r, where theta is A over r. So the unit of this measure is radian. Okay, so this is what it is saying. So you have an angle theta here. Okay, so this is called, this part is called arc length. Okay, A, and as you know, this is the radius. So theta in radians is A over r. So make sure you know they have the same units. Let's say if A is in centimeters, radius is also in centimeters, or A is in meters, radius is also must be in meters. Let's do some examples here. So what is the measure of theta in radians? So you have this, okay, so theta is here, looks like the radius is 1, okay, arc length, which is this part, is 2. So we are going to find theta, we are going to use this formula, A over r, okay, so 2 over 1, then theta is 2 radians. It doesn't say if it is centimeter or meters, it doesn't give units, but both of them are looks like in the same units. Okay, so 2 over 1 gives you 2 radians. So let's look at this one. B, arc length, as you see, is 1 unit and radius is 1 unit. So 1 over 1 gives you 1 radians. So let's look at example C. So this has angle theta, and this whole thing is A, as you see, okay, and that is 8.46 units. So 8.46 over radius is 2. Then this gives you, if you divide it, 4.23 radians. Okay, how many degrees is 1 radian? Okay, how many degrees? So this is how we are going to do it. First of all, 1 revolution using the degrees, 1 revolution is 360 degrees. Okay, so you know that. Okay, so let's try to calculate that 1 revolution in terms of radians. So A over r, right? What is A if you are making a full turn? What is this circumference when you're doing 1 revolution? You're going over this circumference one full time, right? So then what is circumference? 2 pi r. So arc length becomes the whole circumference of this circle if you're doing 1 full revolution. So 2 pi r. Okay, we divide this by r, right? A over r. So that gives you then, r and r is gone, 2 pi radians. So this means 360 degree equals 2 pi radians. Or, you know, if you want to calculate the approximate value, you can replace pi with 3.14. So that gives you 6.28, right? Radians is same as 360 degree. So look at the differences, right? You were working with bigger numbers when you are working with degrees. Now very smaller numbers now. 360 degree is same as 6.28 radians. Something like this. Okay, having said that, so now we kind of prove that 360 degrees is 2 pi radians. Then how would we calculate, you know, 1 radians equals how many degrees? That's what we want to know. So we can use ratios to do that. So we just said that 360 degree is 2 pi radians, right? 360 is same as 2 pi radians. How about, you know, we want to find what 1 radians in terms of degrees, right? So we want to know in degrees. So if you do cross multiplication here, you get 2 pi times x equals 1 times 360. So 360 over 2 pi is what x is equal to. Okay, so if we do 360 over 3.14 times 2 gives you 6.28. So we are dividing 360 by 6.28, 57.3. Okay, this is approximate value, so 57.3 degrees. So means 1 radians equals 57.3 degrees. Okay, so now find the equivalent radiant measure for the following special angles. 360. We already found that, right? It is 2 pi. Okay, then 180 pi, right? It is half of 360. That should be pi. How about 90? Pi over 2, right? Pi over 2. So you now 90 is half of 180. So you get pi over 2. Okay, 60 degree. Well, this is kind of 180 divided by 3, correct? 180 is pi, so pi over 3. How about 30 degree? Pi over 6, so it is half of 60. So pi over 3 divided by 2 gives you pi over 6. 45 degree. Pi over 4, it is half of 90 degrees, so pi over 2 gives you pi over 4. 330. 330 degrees. So you can compare it with 30. Can we say 330 is 11 times 30 degree? Right? So I can write 330 as 11 times 30 degree. 30 is pi over 6, so 11 times pi over 6 gives you 11 pi over 6. Second way of doing it, we can write 360 as 360 minus 30 degree, correct? Can we do that? We know 360 is 2 pi, 30 is pi over 6, so you can have common denominator. That would also give you 11 pi over 6, 11 pi over 6. Okay. How about 315? 7 pi over 4, right? You can either say, oh, okay, this is equals to 7 times 45 degree, correct? 7 times 45 gives you 7 pi over 4. Another way of doing it, 360 minus 45 degree. 360 is 2 pi, 45 is pi over 4. Have a common denominator and simplify, you still get 7 pi over 4. 120. 2 pi over 3. So it is 2 times the 60 degree. 60 is 2 pi over 3. Then this is 2 pi over 3. 150. 5 pi over 6. So you can this can be written as 5 times 30 degree. So 5 times pi over 6. So 5 pi over 6. Of course, this could be also written as 180 minus 30 degree, and that would still give you the same thing. Okay, in general, we can use the following to convert degrees to radians or radians to degrees, okay? So this is how it goes. So degrees over 180 equals radians over pi. So this is the ratio that you will use to convert radians to degrees and degrees to radians. Convert each of the following radians. Okay, we're going to convert 240 to radians. Give the approximate and exact measures. So that's how it goes, right? So 240 degrees are given, okay, over 180 equals, we are looking for the radians, x over pi. So now you can simplify this fraction here. 240 zeros are over 180. Zeros are gone. 24 and 18 both are divisible by 60 as 6. So you get 4 over 3. Okay. Now if you do cross multiplication, so you get 4 pi equals 3x. So x is 4 pi over 3. So to get the approximate value, so you need to use your calculator. 4 times 3.14 over 3. 4.18 or 4.19 or 4.19 is approximate value. So let's do the other one. 43 degrees. So 43 over 180 equals x over pi. So 180x equals 43 pi. So x equals 43 pi over 180. That would be the exact value. So to get the approximate, again you replace 43 by 3.14. Okay, so 43 times 3.14 over 180, 0.75. So x approximately 0.75 radians. So let's look at the next one. 20 degrees. 20 over 180 equals x over pi. So let's simplify. 0 and 0 is gone. Simplify 2 and 18, which is 1 over 9. Do cross multiplication. 9 times x equals 1 pi. X equals pi over 9. Let's look at the approximate. This is exact value. Approximate would be 3.14 over 9, 0.35. Approximately 0.35 radians. Now example 5. Convert each of the following to degrees. So this time it's opposite, right? They are giving you the angle in radians and asking you to convert it to degrees. So correct it to 2 decimal places if necessary. Okay, so we have 13 pi over 4. So 13 pi over 4 over pi equals x over 180. We are using again this ratio. So simplify pi and pi. So you get x over 180 equals 13 over 4. Now do cross multiplication. So that gives you 4x equals 13 times 180. 13 times 180 is 3000. Actually, we could simplify this 4 and 180 first, right? So that would give you, divide 180 by 4 gives you 45. So 13 times 45. So 13 times 45 gives you 585 degree. Okay, so 1.241 radians. Again, x over 180 equals 1.241 over pi. So cross multiplication, isolate for x, you get 1.241 times 180 over pi. So 1.241 times 80, no 180, 180 gives you 223.38 over pi. So that would be the exact value. Now if you replace pi with 3.14, so divided by 3.14, so you get 71.14. It is approximately 71.14 degree. Okay, so it says find theta in radians. So you have arc length 7, radius 3, theta equals a over r. So theta equals 7 over 3 radians. Find the arc length. So this time they give you the radius and the angle theta and asking for arc length. Okay, so theta equals a over r. So if you isolate a from this, so you get a equals theta times r. So a equals theta is pi over 3. Make sure when you are using this formula, theta must be always in radians. You cannot use degrees for this formula. Okay, so pi over 3 times radius is 6, so this gives you 2 pi. Okay, a equals 2 pi, but this 2 pi is not radians. A is because radius is in centimeters. Okay, arc length is also in centimeters. So a is approximately 6.28 centimeters. Let's look at example 8. If a circle has a radius of 20 centimeters, determine the arc length for each of the following central angles. Okay, arc length we are going to find again. So with the previous example, we already isolated A, and we said it is equal to theta times r. Okay, so theta for the first one is 2.35 radians. So 2.35 radians times, and the radius is 20 centimeters. Okay, so 2.35 times 20 gives you 47 centimeters. If you do example B, again A is theta times r. Alright, but look, this theta is in degrees, so you cannot use it for this formula. First you have to convert it, okay? Convert it to radians. So 196 over 180 equals x over pi. So if you simplify this, divide both of them by 4, you get 49 over 45 equals x over pi. So do cross multiplication, you get 49 pi over 45. That is x. So means, 196 degree equals 49 pi over 45 radians. So now you use that value, okay? 49 pi over 45 radians times the radius, which is 20. So divide both of them by 5, you get 4 and 9. 4 times 49, 196 over 9 pi centimeters. And you can replace again pi with 3.14. 196 times 3.14 over 9, 68.38. 68.38 centimeters is the arc length.